Hi, my name is Lourdes Rodriguez, and this is my Midterm 1 Partial Credit Correction video for Econ 151A. In this video, I'll be going through each question I got wrong. For every question, I'll explain what I did wrong, walk through the correct solution step by step, and share what I learned. The topics I'll cover are welfare budget constraints, reservation wages, utility maximization, income and substitution effects, labor supply elasticity, and the labor force participation rate and unemployment rate. Let's get started. Question 1A asks us to graph the budget constraint of a single mother who is eligible for welfare. Here are the key facts from the problem. Her wage is $15 per hour, her total available time is 400 hours per month, and she receives the welfare benefit of $750, as long as her wage income stays below $3,750. To draw this graph correctly, I first need to find where the welfare cutoff happens in terms of hours worked. I set 15 times H equals to $3,750 and solve. That gives me H equals 250 hours worked. Converting that to leisure, L equals 400 minus 250, which is 150 hours. And at the kink point, her total consumption is 15 times 250, plus the $750 welfare benefit. So in total, that makes it to be $4,500. That is our key kink point. Now, here's the important part. If she works more than 250 hours, her wage income exceeds $3,750, and she loses the welfare benefit. So at L equals 150, the budget line drops discontinuously from $4,500 down to $3,750. That vertical gap is the discontinuity. The segment below the kink continues with the same slope of negative 15 up to the y-intercept at 0,6,000. What I did wrong on my exam was mislabeling the graph and drawing the kink and the discontinuity incorrectly. The key lesson here is to always find the welfare cutoff in hours first, then carefully label every key point. Part B of question A adds a work requirement. She must now work at least 80 hours per month to receive the welfare benefit. This creates a second discontinuity in the graph. Starting from the right, if she works fewer than 80 hours, more than 320 hours of leisure, she does not qualify for welfare. At L equals 320, exactly 80 hours worked, she earns 15 times 80, which in total is $1,200. The moment she hits 80 hours worked, welfare kicks in. Her consumption jumps up from $1,200 up to $1,950. That is an increase of $750. That's the first discontinuity at L equals 320. Then the income cutoff kicks in again at L equals 150. Once her earnings hit $3,750, she loses welfare and the line drops from $4,500 back to $3,750. That is the second discontinuity. So the graph has two jumps, one up at 80 hours worked and one down at the income cutoff. What I got wrong was the representation of these discontinuities and incomplete labeling. The takeaway is that the work requirements always create a jump up at the minimum hours threshold. Part C of question 1 asks, if she was working 50 hours per month in Part A, how does adding the work requirement from Part B change her hours? What I got wrong was failing to identify the substitution effect. I incorrectly described this as only an income effect. The work requirement doesn't just change income, it changes the price of leisure too. So if she takes leisure instead of working, she loses the $750 welfare benefit. That makes leisure more expensive relative to consumption. And because leisure is now more expensive, the substitution effect tells us she should substitute away from leisure and toward more work. This is the key insight. So the result is that even though she chose 50 hours in Part A, the work requirement incentivizes her to increase to at least 80 hours, because that's where the welfare benefit kicks in. The lesson here is that requirements act as a price change for leisure, not just an income change. Part D asks, for the reservation wage under both budget constraints, the reservation wage is the minimum wage that makes the person willing to work at all. The formula is reservation wage equals to the marginal rate of substitution. In this video, we will shorten that to say MRS. So, it equals the MRS evaluated at the endowment point, the point where hours worked equals 0. First, I derive the MRS. The utility function is U equals C times L squared. MU sub C equals L squared. And MU sub L equals 2CL. So, MRS equals MUL over MUC, which simplifies to 2C over L. For Part A, the endowment is that L equals $400 and C equals $750, because at 0 hours worked, she still gets the welfare benefit. Plugging in 2 times 750 divided by 400 equals to $3.75 per hour. That is her reservation wage for Part A. For Part B, the endowment is different. At 0 hours worked, she doesn't meet the work requirement, so she gets no welfare. C, or consumption, equals to 0. So, the MRS equals 2 times 0 divided by 400, which is 0. Her reservation wage is at $0. Any positive wage will get her to work. What I did wrong was applying the MRS formula incorrectly and not recognizing that the endowment point changes between parts. Always evaluate the MRS at H equals 0 with the correct C value. Now, moving on to question 2. This is about finding Jose's optimal choice. His utility function is U equals C squared times L. He earns $10 per hour, can work up to 16 hours per day, and has a $20 in non-wage income. I left this question blank on my exam because I simply did not know how to set it up. But here's the correct method. Step 1 is the budget constraint. C equals 10 times 16 minus L plus 20, which simplifies to 180 minus 10L. And step 2 is to derive the MRS. MUC equals to 2CL, and MUL equals C squared. MRS equals C squared over 2CL, which simplifies to C over 2L. Step 3 is to set the MRS equal to the wage. C over 2L equals 10. Solving for C gives C equals to 20L. Step 4 is to substitute into the budget constraint. 20L equals 180 minus 10L. Adding 10L to both sides, 30L equals to 180. Dividing L star equals 6 hours. And step 5, C star equals 20 times 6 equals $120. So the optimal choice is 6 hours of leisure, $120 of consumption, and 10 hours of work. Part B uses the exact same method, but now the wage is $40 per month. Per hour, not per month. The new budget constraint is C equals 40 times 16 minus L plus 20, which gives 660 minus 40L. The MRS formula is unchanged since the utility function is the same, C over 2L. Setting the MRS equal to the new wage, C over 2L equals 40 minus, so C equals 80L. We're going to substitute. 80L equals to 660 minus 40L, giving 120L equals 660. So L star equals 5.5 hours. And consumption jumped from $120 to $440. The higher wage makes working so much more rewarding. My mistake, I left this blank too, so the method never changes. Only the numbers in the budget constraint update when the wage changes. For question 3, it is asking me to draw a graph showing what happens when wages fall from $20 to $10 per hour. We are told that more leisure is chosen when the wage falls, and leisure is a normal good. Step 1 is that both budget lines must pass through the endowment point E. The endowment is fixed. It is where hours worked equals 0, so it does not change when the wage changes. Step 2 is the new budget line is flatter. The slope equals the negative wage, so the old slope is -20 and the new slope is -10. A flatter line means a lower opportunity cost of leisure. Step 3, we are figuring out the new optimal point is to the right and below the old one. More leisure is less consumption, so what matches is what we're told. My mistake is that I drew the graph, but missed the slope labels, axis labels, and didn't clearly mark both optimal choice points. So make sure to always label everything explicitly. And part B of question 3 asks for the direction of the income effect on consumption and leisure from this wage decrease. The key logic is that a wage decrease reduces income. You earn less per hour, so your real purchasing power falls. For normal goods, when income falls, demand falls. Both consumption and leisure are normal goods. The income effect on consumption is negative. The fall in income reduces the amount of consumption. Therefore, IE sub C is less than 0. The income effect on leisure is also negative. The fall in income reduces demand for leisure too. IE sub L is also less than 0. What I got wrong was writing IE sub C as positive. I had the consumption sign backwards. The memory trick is that for normal goods, the income effect always matches the direction of income. Income falls, IE is negative for all normal goods. For question 4, it asks us what a labor supply elasticity of -1.5 means in words. I just lost the point for only addressing one of the two parts. The labor supply elasticity formula is the percent of change in labor supply divided by percent change in wage. Part 1 is the magnitude. The absolute value of -1.5 is 1.5, which is greater than 1. This means that labor supply is elastic. A 1% change in wages leads to more than 1% change in hours worked. Part 2, we're talking about the direction, and this is what I really missed. The negative sign means wages and labor supply move in opposite directions. When wages go up, hours worked goes down. This is the backward bending region of the labor supply curve. So the full answer is that a labor supply elasticity of -1.5 means labor supply is elastic, and wages and hours worked move in both directions always state the magnitude and the direction. Question 5 asks how we define the labor force participation rate in the United States. The formula is LFPR equals the labor force divided by the adult population times 100. The labor force includes two groups: people who are employed, meaning they have a job, and people who are unemployed, but actively are searching for work in the past 4 weeks. The population base is everyone 16 and older who is not in the military or institutionalized. Many groups are not counted, such as retirees, full-time students, stay-at-home caregivers, discouraged workers who stopped looking, and anyone who is not actively seeking for work. The key distinction is that being without a job is not the same as being out of the labor force. What I got wrong was the incomplete definition. I gave the formula but didn't clearly explain who is and isn't included. The keyword is actively searching. For question 6, it asks us how we define the unemployment rate. The formula is unemployment rate equals to unemployed workers divided by the labor force times 100. Notice that the denominator is the labor force, not the total adult population. That is different from the LFPR. To count as unemployed, a person must meet 3 conditions. They must be without a job, they must have actively searched for work in the past 4 weeks, and they must be currently available to work. People who don't count include discouraged workers who gave up looking, underemployed workers, and everyone simply not in the labor force. The unemployment rate does not count all people without jobs, only those who are actively looking. To lock in the difference between the two formulas, the LFPR uses the entire adult population as the denominator. The unemployment rate only uses the labor force, a smaller number. So my mistake was my definition was simply incomplete. I did not emphasize the actively searching requirement. And to wrap up, here are the 6 most important things I learned from this assignment. First, for budget constraints, always label every axis, slope, intercept, kink, and discontinuity. Work requirements create extra features. Show both of the jump up when welfare starts and the jump down at the income cutoff. Second, for reservation wages, evaluate the marginal rate of substitution at the endowment point, where H equals 0. Make sure that you're using the correct consumption value at that point because it changes between parts. And third, for utility maximization, the method is always going to be the same. Set MRS equal to wage, solve for one variable, substitute it into the budget constraint. Fourth, for income effects, normal goods always follow the direction of income. Wage decrease means income decrease, so demand falls for both C and L. And fifth, for elasticity, always state both the magnitude and the direction. The sign does really matter. And 6, for the LFPR and the unemployment rate, the key difference is the denominator. Both require people to be actively searching to count. Thank you so much for watching this video.